Okay, again. Safe.
And Doctor, I have also a question regarding
Okay.
yesterday lecture.
Uh-huh.
It's about the AADT equation,
Mm-hmm.
the
What?
part of the days, 4 times 7, and can you explain it, please?
Yeah. It's the number of days for which the data was taken. The number of days for which the data was taken. So on this particular location, the data was taken by two teams. One of those teams took the data for these 4 months and 1 week out of these in these 4 months. Okay, in every month, like in January, April, and July and October, they collected the data for 7 days of each month. Okay, so this is 7 into 4, right? Number of days, 7 days and 4 months, 7 into 4, plus the data which is represented in this table. Now in this table, the data is given by another team, and that team collected data for 7 days again, 1 week, every month now, not selected number of months, but every month. Okay, so this is each value is representing 7 days. Okay, and then we have 7 days of 12 months. So how many days are for how many days the data is given in the second table? That is 7 into 12, 12 months and 7 days of data in each month. So 7 into 12 plus the data from the first table, which is 7 into 4, 7 days again, and only for 4 months. Okay, so 7 into 4 plus 7 into 12, the total will be 112. Did you get it?
Yes, clear. Thank you.
Okay, now moving on, there are some values here, please. Yeah, so for Monday you are saying you got 1925, then 2100. Okay, 1925, 2100. Next, Wednesday. Okay, 8560, 7650, 1733, 1400. The last value seems to be a problem. 3650. I think you forgot to divide it by 4. I think this is the total. So you divide by 4, you get the right answer. How much is it? 913. Okay, thank you. Now adjustment factor. How do we calculate the adjustment factor? Tell me. I have AADT and I have the average traffic of every day. What should I do to calculate the adjustment factor? Tell me. How do I calculate the adjustment factor of Monday, for example? Which one? Okay, Mariam, you are correct. This is how we calculate the adjustment factor for Wednesday and Tuesday. Ah, okay. Okay, divide it. Give me the values for Wednesday and Tuesdays. But Mariam, you are correct. This is how we calculate the adjustment factor 1958, which is ADT, divided by the average traffic of that day, which is 1925. So that gives you 1.02. Okay, let us recalculate Wednesday and Tuesdays. Wednesday 2140 and Tuesday is, sorry, yeah, Thursday. Okay, now go ahead, please. Calculate the adjustment factors for the day. So each time you take the ADT divided by the average traffic of the day. 0.93, okay. 191. 1 again. 1.02. 1.13. Okay, Saturday 0.40, and Sunday. Okay, so you can see a very large range of values, from 0.91 to 2.14. So now you know it can happen. It can happen. Thursday is different than this, huh? You can recheck the values. Maybe my value is wrong. This, it can happen. I can make mistakes. Actually, I do make a lot of mistakes. Okay. So if you calculated the values like you have calculated for the remaining days and you are getting a difference, then I believe your value is correct. Okay, no problem. Now let us move to the calculation of the factors for each month of the year. Okay, I will still make the 3 columns. Month, average traffic, and adjustment factor. Okay, January, February. August, September, October, November. Okay, now for few months or for many months, we don't need any calculation. Why? Because if the value or if the month or traffic in that month was only observed by this team, then they have already given us an average. Okay, so if the first team did not observe a particular month, then for that month I don't need to calculate the average because the average is already given. For example, February. For February, the only value which I have is 2200, and this is already an average for February. For whatever period the data was recorded, this is already an average. Okay, so February value 2200, that's it. March 2000, no problem. Okay, so for the values for months for which I don't have any additional data from table 1, I'll just take the average as it is. Okay, so let me just write down these values. So my life will become easier. So 2200, then 2000, then for May 1950, 1850, 1950, 17, and then 2000. Okay, 17. I had a teacher, chemistry teacher, who used to sing the numbers and the equations. Very funny. Yeah. Obviously, if I do it, you guys will leave the class. Everybody will drop the course. Okay, now for January, what will happen? For January, I have two sets of values. Okay, the first set is this one. Okay, which is basically 7 days, right? 7 values for January. Okay, so I'll just add these seven values here. 2000 plus 2200 plus 2250 plus 2000 again plus 1800 plus 1500 plus 950. Okay, so there's no problem or confusion about these 7 values. Okay, you just add them. For January, I have an additional value here, which is 2250. Okay, I can add it. I can add it as I should add it, and I will, but I cannot add it simply because it is an average of 7 values. It is an average of an entire week. So you cannot just add it as one single value. You will have to add it as a representative of this entire week. So entire week meaning 7 days. So 2250 into 7. Okay, and then again I will divide it by the number of days. So 7 days from the first table and 7 days in the second table, so total 14. So what's the total here? And if you have any question, please do ask me. Give me the average for January. Somebody have a question, please go ahead. So I added all the values from the first table. And from the second table, I took the average value, which was average for 7 days, and multiplied by the 7 to distribute it into number of days, and then divide by 14, total number of days. $2033. Okay. And for April, give me the value for April. So again, add all these 7 values plus 2100 into 7 divided by 14. How much is it? $1909. Okay. Okay, then for July, you add these 7 values, 1700, 1850, and so on, plus 1800 into 7 divided by 14. $1664. Okay. Last one, October. So the last row from table 1 plus 2100 from table 2 into 7 divided by 14. $1985. Okay. So for calculation of adjustment factor, the process is same. ADT divided by the average of the month. ADT is the same. ADT is for the entire point. So ADT doesn't change if you are calculating for monthly or daily adjustment factors. It will remain the same. Okay. So 1958 divided by 2033. How much is it? $196. Okay. Okay, so each time you take the value from this column, the second column, okay, and ADT what we divide by these values. Okay, so I think you can do it. If there's any problem, confusion, please let me know. I believe you can fill up this table now. Okay, so I will leave it up to you. I'm not going into detail right now. Any problem, any confusion? Okay, you can fill up the table, right? You can calculate the rest of the factors. So I'm moving forward. And the values are given here for you to check if your factors are correct or not. Again, if all the values are correct, your procedure is correct, and if you are having a difference in 1 or 2 values, then I believe you are correct and I made a mistake. Okay, so don't worry about it. Now, whatever example we have done previously, whatever examples we have done previously today or in the last lecture, we were talking about calculating factors for a single control count location. Okay, monthly and daily adjustment factors are calculated using the counts taken on a control count location. Okay. We are talking about a statewide counting program. In a statewide counting program, you may have hundreds or even more control count locations. It can happen. In large countries, it can happen that you have hundreds of control count locations. From each control count location, you will calculate a set of monthly and daily adjustment factors, right? Adjustment factors for each day of the week and each month of the year. Later on, you may find that factors from different locations are very close to each other. So instead of keeping them separate, we can merge them together. So instead of having 3 or 4 different sets of factors, we can have one set of factors, a merged set of factors, because you feel that they are very close to each other. Now there are two questions here. The first question is, how can I say, or how will I decide that the factors are very close to each other? What is my criteria? Okay. Secondly, if I decide that the factors are close and I can merge them together, then what is the method of merging them? How can I come up with combining these different factors into one value? What is the method? Answer to the second question is very easy. How do I combine different factors into one value? I just take an average. That's it. You have three different points. So factors from three different points will be merged into an average value, and that's it. Okay, so the answer to the second question is very easy. And we already know it. Even if you give it to a school kid, he may come up with the same solution. Just take an average. What is the answer to the first question? How do I decide if the factors are close enough to be taken average, or the factors are close enough to be merged? For that, the criteria is calculate the average, then take the difference between the average value and the factor of each point. Okay, if the difference is more than plus minus 0.1, the merging is not possible. If the difference is within plus minus 0.1, the merging is possible. Okay, so whenever you are trying to merge factors coming from different locations into an average value, you calculate the average and then you take the difference between the average and each value. If the difference is, if all the differences are less than plus minus 0.1, the merging is valid. If it is not, the merging is not valid. Okay, now you should note that I said the difference for all the values must be within the range. Okay, so you merged 7 factors together. Okay, but out of those 7 for each day of the week, out of those 7, 2 were out of the criteria, plus minus 1.1. That means merging is not possible for the entire set. You cannot say that leave these 2 values out and merge the other 5 values. No, either you merge all the values or you don't merge any value. Okay, either you merge all the values for the given points or you don't merge any value from a particular point. Okay, so merging is either full or not at all. Okay, there's no middle ground here. Okay, let me show it to you with an example. So you see the factors, daily adjustment factors are given for each day of the week for 4 stations, coverage control count locations, 4 control count locations. Okay, and they have numbered the locations as 1, 2, 3, 4. For each location, you see the set of 7 factors. In the last column, they have calculated the average as well. Okay, so you see the average factor for Monday is 1.01, for Tuesday is 1.02, Wednesday is 1.06, and so on. Now let us apply the criteria and see if the merging for these 4 stations is valid or not, is permissible or not. Okay, the average for Monday 1.01. Take the difference of 1.01 with each of the factors for Monday. 1.01 minus 1.05 gives you 0.04. No problem. Our criteria is 0.1. Okay, irrespective of the sign, plus minus both are permissible. So irrespective of the sign is 0.04. So it's less than 0.1 is permissible. Okay, valid. 1.01 minus 1 for station 2. Again, the answer will be 0.01. No problem. 1.01 minus 1.06. The answer will be 0.05. Again, less than 0.1. 1.01 minus 0.92. It will give you minus point. Oh, sorry. It will give you. So the answer for the first 3 were in minus. The answer to the last one will be 0.09. Okay, so again it is less than 0.1. No problem. Okay, so for the factors of Monday, I don't have any problem. If you move on to factor for Tuesday, again you can do the subtraction for each one of them and you can see the result. I will just highlight the values which have a problem. Okay, so 1.02 for station 1 and station 2, station 3 does not have any problem. But if you do 1.02 minus 0.89, which is for station 4 for Tuesday, I'm talking about Tuesday now. So second row, 4th column. Okay, 1.02 minus 0.9 will give you 0.13. So this value is out of the range. This value gives the difference out of the criteria. So you can see it is marked with bold color. Okay, so it is showing that this value is out of the criteria, or it's given a difference out of the criteria. Okay, Wednesday, all values, if you take the difference, are in the range. The difference for all values for Thursday and Friday is also in the range. As I said, you can try it yourself and you can check. Okay, if you go to Saturday, so 0.98 minus 0.85, again it will be 0.13. Our criteria is 0.1, it is more than that. If you do for station 4, it will be 0.98 minus 1.21. So it will be minus 0.23. It is way out of the criteria. Okay, so on Saturday, station 1 and station 4 have values which are giving the difference out of the criteria. Just for the sake of practice, on Sunday, can you tell me if any station gives a value out of the criteria? And if it is, which station it is? Sunday, check the value yourself. Tell me which station is out of the criteria at all. If it is at all, if there is a station which is out of the criteria, then which one is it? Average is 0.92, so you take the difference of 0.92 with each of these values, and you will tell me if the difference for any station comes out to be more than 0.1. Tell me. 1.10 is out, which is for station what? Which is station? Which is station? Station 4. Okay, so always keep in mind that we are the value refers to the station. Okay, the value refers to the station. So we are not just simply taking out the value. We will take out the station, complete station. Okay, so for the sake of convenience, I will mark this value as well, because other values which are out of the, which were giving the difference out of the range are also marked. So this value is out of the range. You are correct. Now, so I gave you the first rule. The first rule was either you merge all the values or you don't do the merging at all. So either I can merge all the 7 values or I cannot merge any value. Okay, so when I got the first value out of the range, this one, then it gave me the decision that these 4 stations cannot be merged together. Like I said, even if one value is out of the range, merging is not possible. Okay, so when I got the first value out of the range, I already have my decision that merging these 4 stations is not possible. Okay, then why did I do this exercise? Why did I do it for all the other days as well? The point was, and now I come to the second rule. The second rule is, if merging for a particular number of stations is not possible, then you take from that group one station out, and then you see if the merging is possible for the remaining stations. Okay, for the remaining segments. So if merging for 4 is not possible in this case, is it possible that I can merge the remaining 3 stations, or for any 3 stations? Can I do the merging for any of these 3 stations? If merging it for 4 is not possible, is there a possibility I can merge 3 stations? Okay, so this brings me to my second rule. The second rule is always take one station or one set of factors out from the group for merging. Never take more than one set out from the merging. Okay, so whenever you are excluding the number of groups to be merged, the number of stations to be merged, take out one station at a time. Okay, because when you will take out one station, your average will change. So if I take out one station from here, I will recalculate the average for the remaining 3 stations. Okay, so the new averages may be fulfilling the criteria for the rest of the 3 stations. Okay, so the second rule is always take one station out at a time. Okay, first rule was you can either merge all the values or you don't do merging at all. Okay, and the second rule is if you have to take, if the merging is not possible, take one station out of the group at a time. Okay, so which station should I take out from this group? Okay, the station which is giving me the differences out of the criteria. Okay, This is happening for two stations, station 1 and station 4. On Tuesday, station 4 is giving me out difference out of the criteria. On Saturday, station 1 and 4, and on Sunday, station 4 again. So station 4 has more problematic values than station 1, right? Station 4 has more values which are not fulfilling the criteria as compared to station 1. So I will take out station 4. Station 4 should be taken out. Okay, so now I will recalculate the average using the remaining 3 stations. Okay, and then I will apply the criteria again. So let me make a table here. The day and the average. Average. Okay, so give me the average of the 3. Merging occurs for each day or per station. What do you mean? What do you mean? Merging, we are merging for each day. We are trying to calculate a single factor for each day. Clear? We are trying to calculate a single factor for each day. Okay, so now for 3 stations, you will calculate an average factor for Monday, Tuesday, Wednesday, and so on. Okay. So give me the average factor for Monday, Tuesday, Wednesday, Thursday for just using the 3 stations. Okay, so I've decided to cross out station 4. Why? Because the values which were out of the criteria most of them were from station 4. Okay, and I don't want to take out more than one station at a time. Okay, so value for Monday. Okay, 1.0406, 1.04, 1.09, Sunday is 1.04. I used to have students so the classes starting from Monday, they will start from Sunday, from the bottom. Okay, so they were always giving me new values. 1.05 is for which day? Thursday. Okay, then Friday and Saturday. Okay, so it's always a good practice if some of you start from the bottom of the table, start calculating values from the bottom of the table, so we have more values in the end. 1.01 and 0.9. Okay, great. That guy was Pakistani. Okay, we always go the other way around and reverse order. Okay, that's our specialty. Okay.
Doctor, I have a question.
Yes, please.
Did we eliminate station 4 because it had two values that were outside the average?
Yes, more values than the other station.
Okay.
There were two stations which had any values out of the range. Station 1 and 4. Out of these, station 4 had 3 values out of the range, and station 1 had only 1 value. So okay. The logical sequence was take out station 4. Okay. Now let us apply the criteria. Is this merging valid or not? Merging of 3 stations. Okay. Now when you are checking, make your life easy. Don't have to calculate the value for each. Don't have to take the difference for each and every value, because we have already done it in the first trial. Okay. So when you did it for the first trial, on Monday there was no value out of the range. Okay. So in the second trial, it will not go out of the range. Okay. If it was already in the range, it will only become better. It will only get close to the average. It will not go away from the average. Okay. So I will only recheck the values which were having the problem in the first trial. Okay, which values are having the problem in the first trial? The bold values and this circled value, right? Now On Tuesday, this value belongs to station 4. I've already taken it out. So this value does not exist in my group. No problem. Wednesday, no values were out of the range. Thursday, no values were out of the range. Friday, same. Saturday. On Saturday, one value belonged to station 4, which was out of the range. It is already taken care of, omitted. And one value from station 1. Now, let us check this value with the new average. Okay, is it now in the range or not? Okay, so the value is 0.85 and the average for Saturday is 0.9. To take the difference, 0.9 minus 0.85 will give you 0.05. So this problem is sorted out now. Even for station 1, I don't have any problem on Saturday. Okay, on Sunday, again, the problem was caused by the value of station 4. I've already taken out station 4, so the remaining stations don't have any problem. Okay, so with every trial, your work or your checking will become easier because you are taking the values which were causing a problem out of the group. Okay, so for the remaining values, just recheck the values which were out of the criteria earlier, and that's it. So from the remaining values of these 3 stations, only this value was out of the range or out of the criteria in the first trial. So if you just check this value, the remaining values are okay. Okay. So any questions, please let me know. You can stop me. Otherwise, we'll move forward.
Doctor,
So
if we found one value that's still outside the average, do we eliminate station 3?
Why station 3? You will eliminate the station which had the value out of the range.
Okay.
We're not going by sequence.
Okay. I get it now. Thank you.
Coincidentally, station 4 was the one which was causing the problem in the first trial. Okay, but we are not going by sequence 4, 3, 2. No. Just see which station was having the problem. Okay. Now, up till now, we have been using daily and monthly adjustment factors. And what should we do with these factors? Okay, we will do the same thing which we have done in the limited network study, which is to take the factor, multiply with the value of a single day and convert it to average. But in a limited network study, the average was for a specific number of days, a week maybe, or 3 days maybe. In a statewide counting program, we are talking about average of the entire year, AADT. So for each coverage location, I'm trying to find out AADT. So you will take the count which is taken on the coverage location, okay, and you will multiply with the adjustment factor of the day on which the count was taken, and then multiply with the adjustment factor for the month in which the count was taken. Okay, so let me brief you what usually happens. So you have counts for multiple days from a control count location. Using those counts, you calculate monthly and daily adjustment factors, like we have done in the previous examples. Okay, then if you have any nearby coverage count location, on that coverage count location, you have a count for maybe 1 or 2 days. Okay, you will take that count and you will find out the nearest control count location, take the factors of that control count location, the monthly and the daily adjustment factors, and the day on which the count was taken on coverage count, you will multiply with the factor of that day, and the month in which the factor was, so the count was taken on coverage count, you multiply with the factor of that month. For example, or I will give you the example in the next slide, inshallah. Okay, so the difference is that in the limited network study, only one adjustment factor was enough because the study itself was so short. But in a statewide counting program, you need the average of the entire year, so you need 2 factors. Okay, let me show you here. So we have a control count location. For that control count location, we have already calculated the daily and the monthly adjustment factors, which you can see in the table. Okay, the first 2 columns are daily adjustment factors. The last 4 columns, monthly adjustment factors. On a nearby coverage location, somebody took a count on Tuesday in July. You can see the statement below the table. What is it saying? A count of 1,000 vehicles was observed on Tuesday in July for a coverage count location. So a clarification here. adjustment factors and the count are coming from two different locations. Okay. The adjustment factors always come from control count, and the statement is telling you the count for a coverage count location. Okay. Now, if you want the ADT for this location on which the count was taken, you will multiply with the adjustment factor of Tuesday and the adjustment factor of July. Tuesday because it was taken on Tuesday, and July because it was taken on July. So 1000 is that count which was taken on the coverage count, and 1.121 is the adjustment factor for Tuesday, and 0.913 is the adjustment factor for July. Okay, so you multiply them, you get 1023. Now, what is 1023? It is average annual daily traffic of the point on which this count is taken. Okay. So now you can see why we were trying to group the factors together. Okay, because each coverage count location or each control count location may have 30, 40, 50 coverage count locations which are near to them. Okay, and if you are combining 2 or 3 control points together, what will it mean? It will mean that for hundreds of coverage count locations, I can use a single set of factors. Okay, so the factor for Monday for maybe hundreds of locations will be the same. Hundreds of coverage count location will be the same. Okay, if you are able to merge them together, so our life will become easier, our calculation will become easier, our database will be smaller, and so on. Okay, so that's why merging is not possible. Merging is good for us, and obviously I cannot generate a data set wide enough or large enough to show you this, but I hope you get my point. Okay. Another thing which we discussed yesterday, and we will do it a small example for today as well, calculating annual VMT. Now tell me, VMT stands for what? Full form of VMT. VMT, full form. Anyone? Vehicle miles traveled. Honey, good. Vehicle miles traveled, which is the product of volume and the length of the segment. If you want to calculate vehicle miles traveled for a segment for the entire year, you will use the equation given for VMT 365 here. Okay, so you take ADT, which is the average for the entire year for the section, multiply by L, which is the length of the section, multiply by 365, which is the number of days in the year. So ADT is for 1 day of the year, so you multiply by 365 to get it for the entire year. So it will give you vehicle miles traveled for the entire year on this section. Okay. So let us do a small example. You can see the table here. This table shows you the counts which are taken on 6 different coverage count locations. Okay, so there are 6 coverage count locations on which they have taken these counts. So for each location, they are showing the station number, the length, the day and month in which the count was taken, and the value of the count itself, 24-hour count. Okay, and we are required to calculate VMT 365 for all these stations. So let me make a table here. I need the station and the ADT and the VMT 365. Okay, so station 1, 2, 3, 4, 5, 6. ADT. Okay, for calculating ADT, I will take the count. Okay, I'll take the count from here, and for these 6 stations, they are saying use these factors. Use these factors. Okay, so I'll use these factors. So the count is 9120. 9120. Multiply by, it was taken in Wednesday and March. Wednesday and March. So Wednesday 1.108. And March 1.1. Second station 10255, Tuesday, September. So 10255, Tuesday 1.121. September 0.884. you can keep on calculating these values. I will ask for the answers in the end. Okay. 16060 Friday, August 16060 Friday 1.015 August 0.882. Okay. And 421 858 Sunday, May 858 9 is 0.949. Station 5 9508 Thursday, December 9508 is last station 11344 done. Friday, January 1.15 January 1.15. Okay, go ahead, please give me the values. How many ones? 4. Okay. 1, 6, 4. 1. Okay, next. Station 4. 16367. Station 5. 11630. Okay, last one. Yeah, fine. 630 is fine. Last one. One 1399. Okay, now if you want to calculate VMT 365, you take this value, multiply by its length. Length is given 3 miles for the first section, so multiply by 3, multiply by 365. Okay, how much is it? It will be a very, very large number, I know. How much is it? One two one seven two zero two zero. Okay, 121722020. Okay, so so in the same way you can calculate the remaining values. Okay, I believe you can do that. Just take the values from this column, multiply with the length which is given in the question, multiply with 365. I believe you can do that. If you have any questions, please do let me know. Okay, the answers are given in the slide. You can check it, and again, if you find any problem with 1 or 2 values, don't mind it. Okay, now we'll move on to specialized counting studies. What are specialized counting studies? Up till now, we were interested in number of vehicles on the road itself. Up till now, whatever counting studies we have discussed, the aim was for them was to find out the number of vehicles on the roads, either on a network or on a segment or an intersection. In a specialized counting studies, our area is our focus is on area, entire area. Okay, so in specialized counting studies, we are trying to find out how many vehicles enter or exit an area, how many travelers exit and enter an area. Okay, so the studies in which we are trying to find out the number of travelers entering and exiting an area, we call them specialized counting studies. In this course, we will discuss 3 specialized counting studies: origin destination, cordon counts, and screen line counts. Today, I will just give you a brief outline for the origin destination counts, which is the most popular specialized counting study, the most common, most popular. So origin means the start of your trip, destination means end of your trip. So a study in which you are trying to find out the start and end of a trip, that is called an origin destination study or origin destination count. Origin destination count can be taken in 3 ways. There are 3 techniques to do it: license plate, postcard, and interview studies. Okay, license plate study is applied in the same manner as we have discussed for travel time studies. So you place observers on the entry and on the entry and exit points of the area. Okay, these observers are recording the license plate numbers of the vehicles entering and leaving the area. In the end, they will come back to the office and then they will match which license plate number was observed to come out of the area and which license plate number was observed to go into the area. So one observer will say this particular guy or this particular vehicle came out of zone 1 and it went into zone 3. So its origin is zone 1 and its destination is zone 3. So in license plate technique, you are recording the license plate numbers on the entry and exit points of the area, and later on you match them to find out in which areas they were coming out and going in. In postcard technique, now what is a postcard? A postcard is a small card. On one side of the card, you have few small short questions, very few, 4 or 5. Okay, and obviously 2 of those questions are origin and destination. What is the origin of your trip? What is the destination of your trip? Okay, the other questions may include travel time, mode choice, and so on. And on the back of the card, you give your address. Okay, so these postcards with the questions are distributed to the travelers on certain locations. For example, on a traffic signal, when the drivers are waiting for the red light, or the drivers are waiting on the red light, or in a parking lot, or at a fuel station. Okay, so these cards are distributed, and then later on, the drivers will fill these cards later on. They are not required to give them to you at that instant, okay, or at that point of time. So later on, they'll fill up the cards whenever it is convenient for them, and they will send it to the address which you have given to them on the back of the card. Okay, so in the end, you will get the responses and you will fill up there. You will know their origin destination. Interview studies, very simple, very obvious. You have a set of questions. You go to houses in the area, and you ask the people about their travel behavior. And obviously, the most important 2 questions for us will be origin and destination. So in postcard and interview studies, you are taking extra information from the travelers. Okay, in both the studies, you are taking extra information from the travelers. But the most important point I said is origin destination. Okay, now how does it work? First of all, the area or the region which you have, you divide them into zones. Okay, and these zones will be the origin and destinations for the travelers. Okay, so you have an entire city or entire country, and you divide it into smaller zones, and you are trying to find out number of people coming from each zone and going into the other zone. Okay, now whatever data you collect from whichever technique you use, you represent the data in the form of a matrix. The matrix is shown as a table on the slide here. So you can see rows are showing the zones as destinations. So people are going into these zones, and the columns are showing the zones as origins. So people are coming out of these zones. So for example, the first number in the matrix is 50. Okay, for number 50, the first column, first row, the origin is zone 1, destination is also zone 1. So this guy did not go out of his zone for his trip. These 50 guys did not go out of their zone for their trip. Okay, the next number is 8, second row, second column, first row. So for these 8 travelers, the origin is zone 2, the destination is zone 1. Okay, they came out of zone 2, they went into zone 1. Okay, now you see the diagonal numbers in this matrix 50, 65, 38. They are known as intrazonal trips. Intrazonal trips. Trips for which the travelers did not go out of their zone, their respective zones, their origin destination was the same. So we call them intrazonal trips. Okay. Now you can see the summation for each column given here, 88, 99, and so on. And summation of each row is also given here, 95, 106, and so on. So what is 95? Number of trips which went into zone 1. What is 106? Number of trips which went into zone 2, and so on. What are these numbers? The column summations. Number of trips which came out of each zone. So 88 came out of zone 1, 99 came out of zone 2, and so on. Okay. Now these numbers are a sample of the actual number of trips entering and exiting the area. They are a sample. Why? Because any of these techniques cannot give you the exact number of travelers between origin and destination. For example, license plate number. If you are recording license plate number, it is impossible for any observer to record the license plate numbers of all the cars. So you are just recording a sample. Postcard. Many travelers will not receive your postcard. Many travelers will not give it back to you. Okay, so again, it's a sample. Interview studies. It is impossible to interview each and every traveler in our area within a practical amount of time. Okay, so any of these studies will just give you a sample. So this matrix, these numbers which we are showing in the matrix are just a sample. So to calibrate this sample to give us the exact number of trips between origins and destinations, we take a count from the field. And that's why you see an extra column and extra row in this matrix. So you see the last column, volume. You see the last row, again, volume. Which volume is it? The last row, the last column is showing the volumes which were going into each zone, actually in the road, on the road itself, on the roads itself, themselves. Okay, so 250 trips were observed to go into zone 1. 310 were observed to go into zone 2. Okay, similarly 210 were observed to come out of zone 1, 200 were observed to come out of zone 2, and so on and so forth. Okay, so although these techniques give us the exact origin and exact destination of a trip, but they are not sufficient, or they are not able to cover the entire population of travelers. Okay, so to calculate the exact number of trips for each origin destination, we take the volume from the field itself. So this volume, in this volume, we just counted the number of vehicles. It's just a simple count. Okay, counting number of vehicles entering, counting number of vehicles exiting, without bothering from where they came or where they are going. Okay, so how to use these numbers, the volumes, to calibrate the origin destination matrix? We also call it the OD matrix. We'll look at it in the next class. Okay, so today we have discussed the adjustment factors, their application, calculation of VMT, and then we started with a specialized counting study of origin destination. I've just described how to prepare the origin destination matrix, the techniques, and why we need to calculate why we need to observe the volume in the field. Any questions, problems, please go ahead. Let me know. Do you have any questions or problems? Anything you want to say? Any comments? Please go ahead. So in the next lecture, inshallah, we will finish this topic. And then no questions then. So yes, thank you. Welcome. And have a nice couple of days. See you inshallah on Thursday. Assalamu alaikum.